Well, welcome to lesson 1.3, measuring and constructing angles. We're looking at our student notes. Our learning targets for this learning are for measuring angles and working with angles. So you'll be able to name and classify angles, that you'll be able to measure and construct angles and angle bisectors. The construction part we're going to actually hold off on to until a later date this week, and be able to solve for a given angle. An angle is defined as is formed by two rays with a common vertex, with a common end point or start point. So in this particular case, we have this angle. It's named in a couple different ways, so we're going to talk about naming it at the bottom. That common end point is called the vertex of the angle. The interior of an angle is all the points between the two rays. So every point over here that I'm drawing in green or putting in green is on the interior. An exterior of an angle then would be all points outside of those two rays. All points outside of those two rays. So those ones I did in purple, but it's a little tough to see, so I'll just make them bigger. Those bigger points are on the exterior. That is the exterior. And the tiny points are the interior. When we name angles, we actually have a couple ways to name them. We can name them by their vertex. If it is a single angle, such as in this case, I only see one angle there. The vertex is B, so I could call it angle B. And that is the notation we use for the angle symbol. It's like part of a triangle, the corner of a triangle. We could also name it by 3 capital letters, but the vertex must be in the middle. The vertex must be in the middle. So in this case, I could call it angle ABC or angle CBA. So it's the order that I would connect them. B would be in the middle. ABC or CBA if I were drawing from one point to the next without picking up my pencil. But I could not call it CAB because A is not the vertex. B has to be in the middle because it is the vertex. A third way to name them, sometimes we do this because we have to use 3 letters when there's more than one angle, because if I drew another angle here and gave it a point and I just said angle B, then we wouldn't know which vertex are we talking about. Are we talking about this angle, or are we talking about the new angle I've drawn? Are we talking about the larger angle? There would actually be 3 by drawing another ray. So if it's just one angle, then we can just use the vertex, angle B. We can use 3 capital letters. We have to use 3 capital letters if there's more than one angle. And sometimes we'll have a number inside, not the measure of the angle, but just a number without a degree symbol or anything else to show us that they're naming the angle. It's not as common, but we do use it sometimes by numbers. So in this case, this one would be called angle 1. Naming angles. A surveyor recorded the angles formed by transit, point A, and 3 distant points, B, C, and D. Name 3 of the angles. So transit being point A, so that's our vertex. And distant points, B, and C, and D. So that actually gives me 3 different angles. One of them is not too bad. It's angle BAD. It's the larger angle. So BAD is this big angle right there. Another one is this small angle right here. It goes from B to A to C, so angle Bach. BAC. You could also call that angle CAB. Just like on angle bad, you could actually call it angle DAB. Those are really the same angle, so if you name those, they're not two different angles, they are the same. And then the last one that I'm going to name is this one over here, and I'm using different marks to show that they're different. I'll talk about that in a second. Basically, actually I'll talk about it in just a second. So we have CAD, angle CAD, or angle DAC. Now the reason I use this, I used one large arc mark here, but that's not the same as this, so I did 2 arc marks here, which is not the same as this, so I did 3 arc marks here. Basically, when we get to congruent angles, we'll be using arc marks instead of tick marks like we did for congruent segments. But by marking them with 1, 2, and 3, I showed that they're all different. Which of the following angles are angles in the diagram? Well, F is not really a vertex because BF, well, let's take a look. Look, BAC is what we're being asked for first. So we're going to do that one first, BAC. So BAC, if I trace that, those are 2 rays, and it has a vertex. So yes, that is an angle. A is a vertex connected by 2 rays. Angle ABC. ABC. The problem is BC is not a ray. So this is no. Angle ECA. ECA. Well, AC is a ray, but EC, oh wait, EAC, sorry, EAC. EA and AC are rays, 2 rays, so this is yes, and A is a vertex. DAC. DAC, that again is 2 straight lines, 2 rays, so this is yes. AFE. Unfortunately, FE is not a ray, so this is no. And then ADC is also no because DC is not a ray. We'll be talking about the degree and protractor postulate in the next video clip.